4, that is stereoisomerism. So unit 4 is stereoisomerism. So in this class, I'm going to discuss about optical activity of organic compounds. This belongs to unit 4. So unit 4 ali optical activity of organic compounds. Optical activity of organic compounds. So you know that any chiral carbon versus optical activity. So chiral carbon is those optical activity. The stereogenic center, this is a stereogenic center. If it is stereogenic center means it's a chiral. So chiral shows optical activity. So need not to be a carbon, it will be a nitrogen also. Need not to be, it can be a quaternary nitrogen atom. The nitrogen of an ammonia. So it may be a nitrogen, quaternary CS3, CS2, CS3, CS, CS3. See, this is also chiral, but here nitrogen. So nitrogen attached to four different groups. Apart this also chiral is chiral. Any molecule possess chiralness shows optical activity. What is optical isomerism? Optical isomerism andre ಏನು? So optical isomerism when four separate groups are attached to carbon, when four separate group attached to carbon, so this is chiral. So attached to carbon atom, it is possible to have one more molecule that is non-superimposable. This mirror images, but not superimposable. See, this mirror image, but not superimposable. So when four separate groups are attached to carbon atom, it is possible to have a non-superimposable mirror image of the molecule. This is called optical isomerism. This is called the definition optical isomerism. Mirror image is not superimposable, but compound is chiral. So this is called optical isomerism. This is called optical isomerism. So optical isomerism in allenes. Optical isomerism in allenes. Optical isomerism in allenes. So in allenes, optical isomerism in allenes. So what are allenes? So allenes are compounds with two or more double bonds. So ಏನಾಗಿರುತ್ತೆ side by side overlap ಆಗುತ್ತೆ. Allenes. So this is allene. Allenes are compounds with two or more. So this is two or more double bonds. So two or more double continuous ಇದರ ಏನಾಗುತ್ತೆ ಬಾಂಡ್ ಆಗಿರುತ್ತೆ, ಅದನ್ನ ಕ್ಯುಮ್ಯುಲೇಟೆಡ್ ಡಬಲ್ ಬಾಂಡ್ ಅಂತ ಕರೀತೀವಿ. ಕಂಟಿನ್ಯೂಸ್ ಈ ತರ ಆಗಿದೆ. This is called cumulated double bond. So cumulated double bond. So it substitutes anything. Take this is A, B, this is C, and this is D. So here So there is more than 2 or 3, more than 2 double bonds, more than 2 or more double bonds. Acha ಏನಾಗಿರುತ್ತೆ, it's a continuous link ಆಗಿದ್ರೆ ಕಾರ್ಬನ್ಗೆ, that is called cumulated. Cumulated double bond ಅಂತ ಕರೀತೀವಿ. This cumulated double bond. Accumulated double bond. These molecules are called allenes. Allenes andre, so allenes means compounds 2 or more double bonds. So accumulated double. Here even number of double bond. Here even number of double bonds. See 1, 2 is 1 with 2. Here odd number of double bond. 1, 2 and this is 3. Odd number of double bonds. More than 2 irಬೇಕು. This called what? Allenes. See the bonding here irutte andre, bonding here, if it is the first carbon, this first carbon, so this one empty p orbital is H and this is H carbon allene. So next ಏನಿರುತ್ತೆ, ಒಂದು ಸಿಗ್ಮಾ ಬಾಂಡ್ ಇರುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಒನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಆಯ್ತಾ, ಒನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್. ಅಗೇನ್ is central carbon and this last carbon is last carbon. If you take this, say this one, this one p orbital and this is this p orbital. So this is also carbon and this is carbon. The bonding. See, in the first, these two sides will overlap. First, carbon. So there are them. Side will overlap. See, these E double bond. This double bond is perpendicular to this double bond. Perpendicular to this double bond. So ಒಂದು ಹೀಗಿದ್ರೆ ಇದು ಈ ಪೈ ಬಾಂಡ್ ಇದೆ, ಹೀಗಿದ್ರೆ ಈ ಪೈ ಬಾಂಡ್ ಈ ಸೈಡ್ ಅಲ್ಲಿ ಓವರ್ಲಾಪ್ ಆಗಿದೆ. ಸೊ ಇದೊಂದು ಇದು ಮತ್ತೆ ಇದು, ಸೊ ಇನ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಓವರ್ಲಾಪ್ ಆಗಿದ್ರೆ ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಒಂದು ಪೈ ಬಾಂಡ್ ಇನ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇದ್ರೆ ಇನ್ನೊಂದು ಪೈ ಬಾಂಡ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದೆ ಆಯ್ತಾ. ಸೊ ಇದನ್ನ ಏನಕ್ಕೆ ಬರ್ಕೊಳ್ತೀವಿ ನಾವು, can write this one, it is carbon, so this pi bond and one sigma bond and again pi bond, sigma bond, and this carbon, this hydrogen, this finally hydrogen. So this hydrogen, this allene, structure of this allene. What is the hybridization of central carbon here? The central carbon hybridization is sp. Middle carbon. What about end outer carbons? Outer carbons ಏನಿರುತ್ತೆ ಇದು sp2. sp2 hybridization. ಇದು sp2 hybridization ಆಯ್ತಾ. ಯಾವ್ದು ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಯಾವ್ದು ಇರುತ್ತೆ, sp hybridization ಮಿಡ್ಲ್ ಒಂದು ಇರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಔಟರ್ ಕಾರ್ಬನ್ is outer carbon, middle one. This middle one sp, this outer is sp2. Trigonal. This outer trigonal ಇರುತ್ತೆ, ಇದು ಲೀನಿಯರ್ ಇರುತ್ತೆ. This is linear. 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 You know, trigonal. The trigonal 180 degree. Sorry, this is 180 degree. This is 120. This is 180. This bond angle is 120. This bond angle is 120. So allenes. So what is the optical isomerism? Allenes. This is the structure. What is the optical isomerism? Okay, take this allenes, this compound. So this allene. So this is CS3. Next H 2, 3, 2, 3, 2, 3, 2, 3 was pentadiene. 2, 3 pentadiene. Pentadiene. 1, 2, 3, 4, pentadiene. 2, 3 pentadiene. This is, I will take one more molecule, mirror image. This CS3 and this one CS3 is H. This is H. So allenes of the type. This is the allenes of the type. For example, so this AB and this is CD. AB this is A. Here this is B. Here this is C and this one D. But here see A, this is A, this is B. The compound here atom is hydrogen, the B is CS3. So different. A is different from B because B here CS3, but H here A. That's why A H is not equal to CS3. But it's H is equal to H. So A not equal to B. So A not equal to B in 2, 3 pentadiene. Pentadiene is called A not equal to B. A not equal to B. This is called what? Chiral. Can say this one. Can call this one chiral because A not equal to B. If the substituent is different in this carbon, A not equal to B, then this is chiral. And these two are not superimposable. We can't put this molecule here. Not superimposable. Not superimposable. Can't take this particular. Not superimposable and chiral, and it's not superimposable on its mirror image. That's why it is enantiomers. Mirror images, but not superimposable, are called enantiomers. So this is enantiomer. So this is in this molecule there is a restricted in rotation. Can't rotate this molecule because of double bond. We can't rotate in allenes. We can't rotate because of double bond. We can't rotate. So with say even number of the even number of Okay, we take this one plus 1. So this even number. So 1, 2. So with the even number of double bonds, do not have a plane of symmetry or center of symmetry. Here, center of symmetry here. No. See, this is hydrogen below irutte, above irutte. This below irutte, this above irutte. C is above, this H is below. This plane irutte, that's plane irutte. So the above irutte, you can't, there is no inversion center I, and there is no plane of symmetry. Sigma on the correct plane of symmetry symbol of, there is no plane of symmetry. No plane of symmetry. This symmetry elements illa. Yavaga when A not equal to B daga, thyroid daga. When A not equal to B, when A not equal to B, there is no inversion center, there is no sigma, and therefore must show optical isomerism. It shows optical. It must show optical isomerism and can be resolved into an answer. And that's why it is one more molecule, so you write one more molecule, mirror image, can be resolvable into an answer. This is in case of even number. What about odd number? Odd number of hydrogen. Yes, odd number of hydrogen. See, in odd number of hydrogen, this is a chiral. This chiral. You take this one. CS3 and this is H. And this is CS3. So, any substituent for A not equal to B, because this is a chiral. Like is equal to double bond. Odd number of double bonds accumulated alleles is odd number 1, 2, 3. Odd number of double bonds in accumulated alleles is equal to double bond. So double bond lenge ನಾವು geometrical isomerism ಹೇಳ್ತೀವಿ ನೋಡಿ. Cis, trans and something. E and Z notification. Cis ಇದ್ರೆ Z, trans ಇದ್ರೆ E ಅಂತ ಹೇಳ್ತೀವಲ್ಲ ಆ ತರ. So ಇಲ್ಲಿ ಇದು this is actually this molecule is 1 is 2 and this is 1, this is 2. So upper is 2, 1. So different is there and trans and E notification. Here the molecule is chiral because it contains odd number of double bonds. Odd number of double bonds is ಇಲ್ಲಿ ನಾವು ಡಬಲ್ ಬಾಂಡ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ನಾವು ಸಿಮೆಟ್ರಿ ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡ್ತೀವಿ, ಸರಿ ಜಾಮೆಟ್ರಿ ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್ ಈಗ CS3 ಇತ್ತು, DH, CS3. So this is trans. Molecules trans. Because CS3, HCS3. Other kilos HCS3, HH. That's what is chiral and trans. This much odd is equal to double bond. Odd is equal to double bond. So this is optical isomerism in alleles. Optical isomerism in alleles. Next, Spiranes. Spiranes means twist. Spiranes andre twist. It's derived from Latin word. It is derived from Latin word. It is called twist or whirl anta kariತೀವಿ. So twist. So the molecule is like this. So this is above the plane ring, and this ring is below the plane. This is CS3, and this is H, and this H, this is H, and this one One more you can take CS3. So this mirror image of the CS3 H CS3 and this is H and one so this is mirror image. So this is Spiranes. First Spiranes. Thus, the Spiranes in the curriculum, these are enantiomers. These are enantiomers. So, simply, aline this is aline. The CSTM coding, the HN coding. If you take this one, CSP, and this is H, and this is CS3. Here, one of the double bond is replaced by ring. One of the double bond just replace one double bond into ring. So replace the double bond as ring replace this CS2, this CS2. So this is for the plane methane and sorry, this below the plane methane and this one above the plane. Again, replace this carbon into one more ring. So carbon into one more ring. Will above the end CS2. This is line. This is above the plane. This is below the plane. The remaining CS3 and this H. So this is called spirane. Spiranes and then double bond is aline double bonds. Two double bond is aline double bond. Double bond. Just replace this double bond by a ring. Means CS2. So it's also ring. It's called spiranes. It's called spiranes in the curriculum. So this is spiranes. So next, next spiranes I will already told one nitrogen containing. I will show one example. Nitrogen containing spiranes. So nitrogen containing spiranes. So this is nitrogen okay. So this is nitrogen containing this one next molecule. First, next is one. Okay. So this is H and this is COOH. So here nitrogen is 4 valency, that's why plus it takes plus. It takes plus. So this is the compound. So this compound is there. So please notice that the spiro center is quaternary. So quaternary nitrogen rather than carbon. The spiro center is quaternary nitrogen rather than carbon. This spirane. Two ring on the atom. So this is spirane. So next. In biphenyls. Biphenyls. What is biphenyl and now? So biphenyl. So this is biphenyl. So this biphenyl. So this biphenyl, this C1, this C2, carbon number C1 and C2, this one. So here free rotation is there. So biphenyl, see, biphenyl is optically inactive. Optically inactive. Optically inactive because it easily rotate. So optically inactive, the reaction is small. So here the reason is the molecules so here plane of symmetry. If you cut this molecule, it becomes equalols and mirror images. Both are mirror images. Equalols in mirror image. So that's why it is one above fixed along. Rotate this one. So rotate this one negative. One below this side become above above C2. And this is C1. Again, benzene, you cut this molecule through benzene, above and below benzene, produce again equalols, that is mirror image of each other. So it possesses plane of symmetry, sigma, plane of symmetry. That's why it is optically inactive. That's why it is optically inactive. So optically active the ortho position. The ortho position is substitute. So substitute so restrict due to repulsive force. In the ortho position, if there is a bulky group, group is attached to ortho position, in the ortho position, we restrict the rotation. So that type of molecule is called isomerism. That type of molecule is called isomerism. So for example, I will take this molecule. So biphenyl ortho position ke substitute the substitute ortho position is NO2. This also COOH. So one above or one below. So this is benzene. So benzene is below the counter. So this COH is below, and one more. Is NO2. Is above and is below. So these both are what? Bulky group. Both are bulky group. You can't rotate easily. C1, C2 rotate So rotate So isomers. So in one molecule, same we write this. Okay. We take this molecule. So one more molecule. So this one more molecule COOH, and this is NO2. Again, here NO2, this COH, this NO2, and this one COH. Okay, these two are mirror images, but you can't put here, not superimposable. mirror images but not superimposable. That's why it is enantiomers. That's why it is enantiomers. So 6,6. 6,6 dinitro, 2,2 diphenic acid. Diphenic acid. So possess this mirror. So mirror images, but you can't superimpose. That's why it is enantiomers. It is enantiomers. Is enantiomers. So this is also chiral. So due to restricted rotation, due to bulkier group, this shows bulky. This means if this is in A and this is B and this is D, if condition A not equal to this NO2 and this is COH, so A not equal to B, then is chiral. No, chiral. So A not equal to B. A and this is B. Okay. So next this A and this B. This A and this is B. Biphenyl. If A not equal to B, the chiral. So biphenyl chiral agbekanದ್ರೆ there are 3 conditions. One is A not equal to B. First condition. If the molecules say the biphenyl is chiral, if so 3 conditions. The first condition is A not equal to B. Second condition, restricted rotation. Restricted rotation at C1 and C2. C1 and C2. So next, ortho substituted bulky ortho group. Next, bulky ortho substituted group. Bulky ortho substituted. So one more line. One more need not to be in ortho. It may be ಆರ್ಥದಲ್ಲೇ ಇರ್ಬೇಕಂತ ಏನಿಲ್ಲ. ಸೊ ಇನ್ನೊಂದು ಏನಿರುತ್ತೆ, ಇಟ್ ಮೇ ಬಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ವಾಟ್ ಮೆಟಾ ರೀಸನ್ ಆಲ್ಸೋ. ಆಯ್ತಾ? ಸೊ ಇನ್ ಮೆಟಾ one may be is present in meta position. So meta position ಅಂದ್ರೆ if this is H and this is COH and this is NO2 and this is NO2. ಇಲ್ಲಿರ್ಬೇಕಾಗಿರೋ COH ಚೆನ್ನಾಗಿರುತ್ತೆ. The fourth condition, the bulkier group may also present in COH also. ಅಂದ್ರೆ ಮೆಟಾ ಪೊಸಿಷನ್ ಇದ್ರೂ ಕೂಡ ಅದು chiral. ಒಂದು chiral biphenyl, ಒಂದು biphenyl ನ chiral ಅಂತ ಕರಿಬೇಕಂದ್ರೆ, so A not equal to B and restricted rotation in this C1 and C2 and bulkier group in ortho position, and one may be one of the sequence may be present in COH. One of the molecule is present in COH. ಆಯ್ತಾ? See, to take this molecule, this H, so one H and this is H, COH and this is COH. Bulky group illa andre ಏನಾಗುತ್ತೆ? See, if you draw a line from each atom to center, it means the same atom. which is equidistance from the center, is called what? Inversion center. See? Inversion center present. The symmetry element present. Symmetry present is on achiral. The symmetry present is on achiral ಅಂತ ಕರೀತೀವಿ. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕೈರಾ ಆಗ್ಬೇಕಂದ್ರೆ ಸೊ ಬಲ್ಕಿಯರ್. ಸೊ ಬಲ್ಕಿಯರ್ ಗ್ರೂಪ್ಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲೇನ್ ಮಾಡಬೇಕು COH. So COH here NH COH amide your CH3. This amide. Put this NH COCH3. Here no inversion center. All atoms will be same distance is irrela. So that's why this is chiral. It is chiral. Okay, na? So this is chiral. Next, so the next is R and S. So this is very important. R and S nomenclature. R and S nomenclature. R and S nomenclature of allenes. Of allenes and biphenyls. Of allenes and biphenyls. RS nomenclature of allenes and biphenyls. See, this is the molecule. This allene. Is what? Allene. This is A and this is B. And next this is C. This is D. This is allene molecule and biphenyl. So this is the molecule, it's the biphenyl. This is substituted A and this is B, C, and this is D. What about Spiranes? Spiranes also you can write like this. In the double bond with okay, one do replace C, A, and this is B. This allene, biphenyl, spirane. So first allelic compound first tagonna. We take this the compound allelic compound. Aita allelic compound. So if we take this compound allelic, this allelic, weaving the structure along the CC axis, So if you take the allene as the example, so for an example, I will take this one. COH, and next one more you can take about the plane. So this H, COH, and this is H. So this is even number of double bonds. So this is allene. This A not equal to B, this A, and this is A not equal to B, chiral. So how to name this one? So we from this side. If you from this side, you can write like this. You can write. See, I will see like this. This one is above and this ಹಿಂಗ್ ಕಾಣಿಸುತ್ತೆ ನಮ್ಗೆ. ಒಂದು ಮೇಲೆ ಇರುತ್ತೆ, ಒಂದು ಡೌನ್ ಸೈಡ್ ಈ ತರ ಕಾಣಿಸುತ್ತೆ. ಅದರ್ವೈಸ್ ಇದು ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಲೈಕ್ ದಿಸ್ ಎಬೋ ದಿ ಪ್ಲೇನ್ ಕಾಣಿಸುತ್ತೆ. ಇದು ಈ ಕಡೆ ಮೀನ್ಸ್ ಅವೇ ಫ್ರಮ್ ದಿ ಬೋರ್ಡ್. ಅವೇ ಫ್ರಮ್ ದಿ ಬೋರ್ಡ್ ಎಬೋ ಈ ಕಾಣಿಸುತ್ತೆ. ಹೈಡ್ರೋಜನ್ is away from the board, and this what? This left right hand. See, this is left side, right this hydrogen, this right side COH. Aita remaining you consider the opposite content COH, and this is H. ಫಸ್ಟ್ ಅಸೈನ್ ನಿಯರ್ ಯಾವ್ದಿರುತ್ತೆ ನಮ್ಗೆ ವ್ಯೂವರ್ಸ್ ನಿಯರ್ ಆಗಿರುತ್ತೆ ಅದನ್ನ ಎ ಬಿ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು, ಪ್ರಿಯಾರಿಟೈಸ್. ಇಲ್ಲೂ ಪ್ರಿಯಾರಿಟೈಸ್ ನೋಡಿ, ಎ ವಿಚ್ ಇಸ್ ಎ ವಿಚ್ ಇಸ್ ಬಿ ಮೀನ್ಸ್ ದ ಕಾರ್ಬನ್ ಇಸ್ ಎ ಅಂಡ್ ಎಚ್ ಇಸ್ ಬಿ, ಬಿಕಾಸ್ ಕಾರ್ಬನ್ ಮೇಲೆ atomic number is 6, hydrogen is 1. That's why I take this one A. This is B because only one atomic number is 1. The right side is the left side, and this also the right side kanutte, here the left side kanutte. This means remaining COH and OH. This A and B. Between COH and H, which is the atomic number is more carbon. That's what is A, and this is B and B. Sorry, next is na CD and the. What is this one? Is C and this is D. First, near is the name is this A, left B. This between the hydrogen and carbon, C is more atomic number, that's why C is less B. Then this one, this is ACD or like this. A, B, C, B. This is A, this is B, this is C. A, B, C. So it means R configuration. Right side, rectus and third. That's why it is R configuration. R configuration. Right side bandra first viewer ee kade tagondra like this. R configuration. Like this in biphenyl. Then biphenyl tagondra so take this biphenyl. Okay, so biphenyl is above. So this above andre idu kuda above COOH, and this is nitro. So I take nitro on this. So this nitro. Next COOH, and one more is NO2. NO2. This is NO2. We from this side. This side nodadre we from this side upside aita upside kodare yav barutte first. So A is see right side ge yav kaanustite nimge ee kade nodadre right side ge NO2 kaansutte aita. ಈ ಸೈಡ್ COH ಕಾಣಿಸ್ತದೆ ಆಯ್ತಾ. ರೈಟ್ ಸೈಡ್ ಯಾವ್ದು ಬರ್ಕೋಬೇಕು, ಈ ಸೈಡ್ ನೋಡಿದ್ರೆ NO2. ಸೊ ರೈಟ್ ಸೈಡ್ NO2, ಅಪ್ ಸೈಡ್ ಇಂದ NO2, ಲೆಫ್ಟ್ ಸೈಡ್ COH. So in bottom ಆಗಿದೆ above COH ಕಾಣಿಸುತ್ತೆ. So below inverted content. So V1 ಗೆ ನಿಯರ್ ಯಾವುದು? ನಿಯರ್ ಇಲ್ಲದೆ ಇದಕ್ಕೆ A ಇದಕ್ಕೆ B. V1 ಗೆ ನಿಯರ್ ಯಾವುದು ಕಾಂಪೌಂಡ್ ಇದು. So next benzene ಗೆ so nitro is C and this is D. Why CA? Because between carbon and nitrogen well, atomic number 7, carbon is 6. That's why this is A. It's named A. So that is this takes B because of atomic number 6. So this one. So A. See this is like this. See A, B, C. This coming like this means anti-clockwise. That's why it is yes configuration. So biphenyl ನೋಡಿ ಈ ತರ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ರೈಟ್ ಸೈಡ್ ಆಗಿ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ N2 ಆ ಕಡೆಯಿಂದ ಇದು ರೈಟ್ ಸೈಡ್ ಆಗುತ್ತೆ, ಇದು ಲೆಫ್ಟ್ ಸೈಡ್ ಆಗುತ್ತೆ. ಸೊ ರಿಮೈನಿಂಗ್ COH ಎಬೋ ಇರುತ್ತೆ, ಇನ್ನೊಂದು N2 ತರ ಬರ್ಕೊಂಡ್ರೆ ಅದು ಕಷಾಯ ಮಾಡಿ ಕ್ಲಿಯರ್ ಯಾವುದು ಫಸ್ಟ್ ಇದಕ್ಕೆ ಕಷಾಯ ಮಾಡಿ. ಸೊ AB next is C, this is B, then pair dies according to decreasing. So A B C. So that's anti-clockwise direction, that is S configuration. So X configuration ಅಂತ ಕರೀತೀವಿ. So this is nomenclature of RS nomenclature for alkenes and biphenyls. What is cyclophanes? Syllabus mention ಮಾಡಿದ್ದಾರೆ cyclophanes. So cyclophanes ಅಂದ್ರೆ is a phenol. O ಅಟ್ಯಾಚ್ ಆಗಿದ್ರೆ ಏನದು ಫೀನಲ್ ಅಂತ ಕರೀತಾರೆ. ಪ್ಯಾರಾಫಿನಲಿನ್, this is paraphenyl. So this paraphenyl, so having two paraphenyl subgroups, that is groups end face to face, at the end what face to face by this is CH2N group. N type CH2 repeat ಆಗಿರುತ್ತೆ by CH2N bridge. And ಇದು bridge ಇದು CH2 bridge, CH2 repeat ಆಗಿರುತ್ತೆ. This is paraphenyl. So this is paraphenyl. The cyclophanes are compounds having two paraphenyl groups end face to face by CH2N bridge. This is called cyclophanes. It's cyclophanes. So it's a much more restricted rotation when what? Take this in R. So this is cyclophane actually. If it is R is substituted with fluorine, it's more restricted rotation. Fluorine atom, then fluorine atom is R or fluorine atom is substitute ಮಾಡಿ R. So this is more restricted rotation. Acquires restricted rotation. R is substituted by F, that was restricted rotation. So ನೋಡಿ ring flip ಆಗ್ತಾ ಇರುತ್ತೆ, ಇದು ಆ ಟರ್ನ್ ಆಗುತ್ತೆ, ಈ ಕಡೆ ಟರ್ನ್ ಆಗುತ್ತೆ when R is hydrogen. So this ಎಷ್ಟು ಟೈಮ್ಸ್ more ಇರ್ತಾರೆ ಅಂದ್ರೆ compared to R is equal to fluorine 10 to the power of 11 times flip ಆಗ್ತಾ ಇರುತ್ತೆ. If you substitute this fluorine, it decreases this 10 to the power of 11. The flipping in the hydrogen compound occurs 111 100 to the power of 11 times. If R is H flipping, so it is 100 times 11 faster. If R is substituted with H, it is more flipping than fluorine. That is 10 to the power of 11 times flipping is more compared to fluorine in case of hydrogen. Next, last one, allicins. So allicins. So what are allicins? So allicins are ortho-condensed polycyclic aromatic compounds. So ಈ ಬೆಂಜಿನ್ ರಿಂಗ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಅನಿಲೇಟೆಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಈ ರೀತಿ ನೋಡಿ, ಅನಿಲೇಟೆಡ್. ಸೊ ಆರ್ಥೋ ಕಂಡೆನ್ಸ್ಡ್, ಇದೆಲ್ಲ ಆರ್ಥೋ. ಸೊ ಆರ್ಥೋ ಕಂಡೆನ್ಸ್ಡ್ polycyclic. Polycyclic aromatic compounds. See, polycyclic. See, this can have, right? Mirror image also. See, this is called allicins. So this is called allicins. Okay. So this is called allicins. So this completes fourth unit. So this completes fourth unit. So next we will continue in the fifth unit. So what is the summary of this? Is optical isomers. The summary: optical isomerism. Alins andre eno, isomers andre nomenclature. Biphenyls. Next 4 Spiranes, and next Spiranes admale na. So these are Spiranes. Next allicins. So these are the topics you covered in this session. Okay. Any doubt in this class? So read it first by taking SLM ತಗೊಳ್ಳಿ. SLM ತಗೊಂಡು ಒಂದ್ಸರಿ ನೋಡಿ, ಹೇಳಿದೆ ಇಟ್ಟಿದ್ದೀವಿ. ಮತ್ತೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ಇವಾಗಲೇ ಓದೋದನ್ನ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಅಟ್ಲೀಸ್ಟ್ ಏನು ನಿಮ್ದು ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಇದೆಯಲ್ಲ, ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ತಗೊಂಡು ನಾವೇನು ಟಾಪಿಕ್ ನ ಇಲ್ಲಿ ಕವರ್ ಮಾಡ್ತೀವಿ, ಆ ಟಾಪಿಕ್ ನೋಡ್ಕೊಂಡು ಒಂದ್ಸರಿ ನೋಟ್ ಮಾಡ್ಕೊಂಡು SLM ತಗೊಂಡು ಓದಿ. ಆಯ್ತಾ? ನಿಮ್ದು ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಮೋರ್ ದೆನ್ ಎನಫ್. ನಿಮ್ ಸೀನಿಯರ್ಸ್ 3 ಪೇಪರ್ ಸಿಗುತ್ತೆ, 22, 23. ಸೊ ಎಲ್ಲ ಏನಾಗುತ್ತೆ, ಜನವರಿ ಜುಲೈ ಸೈಕಲ್ ಎಲ್ಲ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ. ಸೊ ಕ್ವಶನ್ ಪೇಪರ್ ಓದಿ, ಫಸ್ಟ್ ಬ್ಲಾಕ್ ಸೆಕೆಂಡ್ ಬ್ಲಾಕ್. ಸೊ ಇಂಪಾರ್ಟೆಂಟ್ ಕವರ್ ಮಾಡಿ. ಅಂದ್ರೆ ಸ್ಕೋರ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಥರ್ಡ್ ಅಂಡ್ ಫೋರ್ತ್ ಬ್ಲಾಕ್ ನು ಓದ್ಬೇಕಾಗುತ್ತೆ. ನೀವು ಚೆನ್ನಾಗಿ ಸ್ಕೋರ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಸೊ ಆಲ್ 4 ಬ್ಲಾಕ್ಸ್ ಆರ್ ಈಕ್ವಲಿ ಪ್ರಿಫರ್ಡ್. ಆಯ್ತಾ? ಸೊ ಓಕೆ. ಸೊ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಏನಾದ್ರು ಇಯರ್ ಬರ್ತಿದೆ, ಮೋಸ್ಟ್ಲಿ ವಿಲ್ ಅನೌನ್ಸ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಮಂತ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಮಂತ್ ಅಲ್ಲಿ ಅನೌನ್ಸ್ ಮಾಡ್ಬೋದು. ಆಲ್ರೆಡಿ ಅದಕ್ಕೂ ಪ್ರಿಪೇರ್ ಆಗಿರಿ. ಸೊ Your examination may be April end. Okay. Next serial. The previous question paper ತಗೊಂಡು ನಾವೇನು ಟಾಪಿಕ್ ನ ಕ್ಲಿಯರ್ ಇಲ್ಲಿ ಕವರ್ ಮಾಡ್ತೀವಿ ಆ ಟಾಪಿಕ್ ಅನ್ನ ನೋಡ್ಕೊಂಡು ಒಂದ್ಸರಿ ನೋಟ್ ಮಾಡ್ಕೊಂಡು SLM ತಗೊಂಡು ಓದಿ ಆಯ್ತಾ. ನಿಮ್ದು ಯೂನಿಟ್ ಇಂದ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಆಯ್ತಾ. ನಾನು ಟೈಮ್ ಇಂಟಿಮೇಟ್ ಮಾಡ್ತೀನಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಯಾವಾಗ ಅಂತ ಗ್ರೂಪ್ ನಲ್ಲಿ ಕ್ಯಾನ್ ಜಾಯಿನ್ ದಟ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
Sir, thank you.
ಥ್ಯಾಂಕ್ ಯು. ಓದಿ.